Alright, 8.2 Similarity in Polygons. Today in class we talked about dilations, about the pre-image and the image. They have the same shape but not necessarily the same size. So if this happens, the figures, they're said to be similar. So similar figures. So two figures are similar. They're similar if and only if if and only if one is congruent to the image of the other by a dilation. So we talked about the dilation and the scale factor today. So they are similar if they're congruent by the dilation. In this dilation, the corresponding angles of the triangle are congruent. The angles are still congruent. And the ratios of the lengths of the corresponding sides are all equal to the scale factor of the dilation. So if you look at this example, it's showing you that angle A and angle A are congruent, angle B and angle B are congruent, angle C and angle C are congruent. So all of the angles are congruent, and then A prime and or AB prime and AB prime, these are all proportional. They have that scale factor of 2. So that's your dilation, a scale factor of 2. The sides of polygons are proportional, so they're proportional when the two ratios of corresponding sides are equal. So when your ratios are equal, these sides are proportionals. And the statement of equality of the two ratios, that's called a proportion. So you've heard those terms before, proportion and proportional. So we're going to start setting up proportions to solve for missing sides. So we have our polygon similarity postulate. Two polygons are similar if and only if there is a way of setting up a correspondence between their sides and angles such that the following conditions are met. If each pair of corresponding angles is congruent, so all of the angles have to be congruent. So A is congruent to D, B is congruent to F, and C is congruent to E. So they all have to be congruent to each other. And the corresponding sides are proportional. So the angles have to be congruent and the sides have to be proportional. If this is true, then the two figures are similar. And remember, in the similarity statement, the letters of the vertices must be written in a corresponding order. So A, B, C has to be written as D, F, E, because that tells you that A matches up with D, B matches up with F, and C matches up with E. So it says both conditions of the polygon similarity postulate must be true in order for the polygons to be similar. What is wrong with the figures here? If you look at these two, oops, sorry, wrong two. If we look at these two, all the angles are congruent, but the figures are not similar because the sides are not proportional. So our sides are not proportional. And if we look at this one here, the sides are proportional, but the angles are not congruent. Corresponding angles are not congruent. We'll say corresponding angles are not congruent. So now we can decide if this triangle is similar. Well, we need to see if the angles corresponding angles congruent. So corresponding angles. So look at our corresponding angles. Well, we know that angle Q is congruent to angle T. So angle Q is congruent to angle T. Angle R is congruent to angle U, and angle P is congruent to angle S. So these are the corresponding angles. So they're all congruent. So that's the first thing. Now we need to look at the sides. Are the sides proportional? Okay, so if we look at ST and PQ. So ST and PQ. So this is 57 over 38, which gives us simplified to 3 over 2. So that's the first side. Then we have TU and TU to QR. So TU to QR is 30 to 20, which also gives us 3 to 2. And then the last one is SU to PR. So SU to PR is 39 over 26, which gives us 3 to 2. So these are all congruent. So these are the same. So these are the same, which means our sides are proportional. And our scale factor is 3 over 2. So since our sides are proportional, our corresponding angles are congruent, we know that triangle PQR, now similar, it's just one line, congruent to triangle STU. If you notice, alright, Q and T match up, R and U match up, and P and S match up. So some of our properties for proportions, the cross multiplication property. So if you cross multiply A times D, B times C, it'll give you this. Reciprocal property, what we can do is flip these, so B over A and C over D, we flip them. The exchange property, so we exchange the B and the C here. And then the last one, add one property, so we can add something to both of the numerators as long as we do it to both sides. So these are just a few of the properties with proportions that we'll be working with. And then we have a couple problems. A real world example one, Drew and Stephanie are making a scale model of a building with a rectangular foundation as shown in the picture. The long side of the model are 24 inches. How long are the short sides? So we know that we have 32 feet over 24 inches because this is our building compared to the model. Well, the building has 18 feet and the model is X inches. This is a 4, not a 9. Alright, so we have our building compared to the scale, so that's how I'm setting up my proportion. So now we can cross multiply to solve this. 24 times 18 is 432 equals 32x divided by 32. X equals 13.5. So the model is 13.5 inches long. Model's short side is 13.5 inches long. So model's short side. Now we can determine if these figures are similar. Well, first thing we look at, do we have all the angles are congruent? So now we want to check our sides. So 25. So 25 is across from our smallest angle. 20 is across from the smallest angle. So we have 25 over 20, which gives us 5/4. Then the second smallest angle is here. So that's 30 across and 24. 30 over 24, which is also 5 over 4, which leaves 35 and 28, which is 5 over 4. So these are similar. So yes, these are similar. Now if we look at the next one, when we look at these, we have all the angles are 90 degrees, so they're all congruent to each other. And then when we look at this, so 36 to 27 is 4 over 3, and 48 over 32, we can divide by, if you divide it by 8, you get 6 over 4, which gives us 3 over 2. So these are not proportional. Not proportional. They don't have the same scale factor. So not the same scale factor. So they're not similar. Not similar. And if we look at the last two, find the missing length. Alright, so this is my x, so AD and EH, so 33 over x, and I can say I have 20 and 12 is equal to 20 over 12. Since they're similar, I can set up my proportion. If you cross multiply, this is going to be 20x equals 396 divided by 20, and x is going to equal 19.8. And if we look at the last one, this matches up with 24, so we have x over 24. Now I can use my hypotenuse, so I'm going to use hypotenuse on both of these, which is going to be 25 over 40. Notice how I did this smaller triangle is both the numerator, larger one is both the denominator. So you get 40x equals 600 divided by 40, and x equals 15. Now that's setting up these proportions using similar polygons.